we can start. The person that I would like to introduce you to is someone with a pretty unique history when it comes to his relationship with U2I. I'm sure he will share during networking how that went and what happened. So be sure to ask about his broad experience with our company. Przemek Syktus. He is a software engineer with over a decade of experience. He enjoys learning new hobby every year, so that's another conversation starter for you. And he really loves to understand how things work. Today he will be telling you, or he will tell you, he will not be telling you, he will tell you how we ensure the quality of a data heavy project at U2I. Przemek.
Hello and welcome. Thank you for coming today. I will have the first talk of the day. It will be on the topic of data quality engineering. I will briefly talk about what it is, why it matters, and how we do it. So let me start by briefly introducing myself and the project I work on, which was basically what generated most of the content for this presentation today. You might have already seen my face on some of the posters. As Karolina said right before me, my name is Przemek, and like possibly many of you, I have graduated AGH, University of Science and Technology, quite a while ago. I've been with U2I since 2012. Interestingly, I have actually had a brief link with Qualtrics in the meantime for 1.5 years. So this is what Karolina was referring to. This is also a very data-heavy product-based company. U2I is a software house. What this means is that we work with multiple projects and clients. So I had a great opportunity to work with at least those 4 that I have mentioned here, but also multiple others. And some of them are data related, some of them are not so much. To add some color to my person, maybe let me tell you that my favorite food is curry, specifically Japanese curry, and I really enjoy hiking. And to the great dismay of my neighbors, I started playing the violin last year. They do not enjoy it as much as I do. So without further ado, let me introduce the project that I work on. And the project is called Social Content Ratings, SCR for short. I will be referring to it as SCR from now on. It is a social media listening platform focused on television and sports. This is what it says on our marketing page. What does this mean, actually? So simply put, we check how many people talk about stuff like TV programs, sport teams. On social media, we have various types of social media, which is Facebook, YouTube, Twitter, and Instagram for now. What is interesting about social content ratings is that we have quite a large volume of data. As you can see, I actually checked this today. We have about 10 terabytes of S3 data that we generate every single day. We also delete a lot, but that's a lot of data there. We have a lot of databases, mostly MySQL and Postgres. One of the largest of them is over 3 terabytes large. This is a single instance of MySQL database. It has a single table of over 2 terabytes of data and over 14 billion rows. I was actually trying to get the accurate number in the morning, but the query was running, just the count query was running about 20 minutes before I gave up and decided to stop it. But I do know it is over 14 million rows. So this is very many rows. This is a lot of data, and this data is quite valuable. So one of our product owners likes to say, data is our product. What we sell here at the CR is data. What does he mean by that? This is probably the most important slide I have in my deck, so if you want to pay attention, this would be the time. What he means, when you think about applications, what you are probably thinking about is something like G Suite, like Gmail or Docs or Uber or Pyszne, like this is an application. And you think about what features they offer, you think about what UI they have, what service they provide, what do they do. So most of the apps that people are familiar with are actually this kind of apps. I call it feature-focused applications. It's not an official name. They are usually business to customer, which is why they are so familiar. Many people use them. The primary function is what they do, and what customers pay is the service that they provide and the tools that are available in those apps. What this means is that if you have a new version that you're trying to release, and you release it with some exceptions, you don't really care about the old version, unless you're running a mobile app, in which case you're basically stuck with whenever customers decide to update. Why this is important? So when you release a version that actually has a problem, you can just release a new version that fixes the problem, and the old version goes away, the problem goes away. If you have a web app, they just need to refresh, and it's done. So that's mostly easier. You don't have to care about the broken version. On the other side is the applications that are data-focused. So this is applications that are B2B, which means business to business. They sell to other companies. They are widely unknown. This is many analytics companies have this kind of focus, including us, with SCR at Talkwalker, which is the company that owns SCR. So what those customers care about is not what the application does. They care about what the application data is contained within it. An example of those companies can be Sumo Logic, which maybe some of you know. They deal with logs. SAP, they deal with, I think they own over 60% of medical data in the entire world. And us, we own some social data. So what many people do not realize is how huge those corporations are. So SAP, for example, that I mentioned, this is an analytics company and a data-focused company, is the largest company in Germany, period. No disclaimers. And it is larger than Volkswagen, BMW, Mercedes, all of those companies. And yet many people have never heard about SAP because it is a data-focused application sold to other businesses. So this is also why not many people actually heard about our applications, while it is still a pretty large business. Because the customers that use it are usually other businesses. So back to the example of releasing new version that I mentioned before. With data-focused application, you run into a problem. If you release a new version, you already have all your data generated either by the old version or by the new version that you've been releasing. So there is a data that is being generated constantly as you go, gathered in some sort of ways. If you have a problem, you release a buggy version of your application, you start to generate wrong data. And this wrong data stays even if you release a new version of application. This is a very big difference because you not only have to care about the quality of your application. So if you're testing, if you're running any sort of validation, you just don't have to click through the application. This might or might not help. You also have to check what your data is. So this is much more difficult than it is for the feature-focused applications. And this is where data quality engineering that we do comes in to help. So what do I mean when I say data quality? A few different things. Completeness, which is whether all the data that we had before and that we wanted to generate is still being generated. Also that we do not generate excessive data, duplicates, or anything like that. Accuracy, whether the data that we generate actually represents the reality. So in our case, whether it actually collects the data from social media that we care about. Stability, which is if you query our application, if you look at our application this week, and then if you look at our application next week, you expect the data to be the same for the most part. So if you asked about the report from yesterday now, and then a week from now, it should be more or less the same report. If it changes over time, that means there could be an issue. And also consistency. So this is usually business related. So things like, imagine you are generating a sales report, and that sales report is a daily report. You also have a weekly report. You would expect your daily reports to sum up into your weekly reports. If that doesn't happen, this means you have an inconsistent data set. And this could indicate another kind of problems, and obviously we don't want this. So let's get back to our product, SCR. We have multiple kinds of data. This is a horribly oversimplified diagram of our system. As you can see, it's divided into two parts. In short, what we do is we consume data from Twitter, Facebook, Instagram, YouTube. We collect it, so we call this part of system collection. This can work in two different ways. We either query the current state of some pages, or we have a data stream that's coming from Twitter, like all of Twitter. That's a lot of data as well. And we kind of filter it, save it, and do something with it that it's later available for report generation. This runs mostly in real time, 24/7, all the time. It gathers information about, for example, how many likes a given post about a given TV show has. So if you have a TV show, somebody posts, I watched this show, it was great, somebody likes it, we gather all of this information, we kind of aggregate this, and this later serves the purpose of saying how popular this show is on social media. Łukasz will talk a little bit more later about how we do this specifically, and I will move on to the reports. This will come into play shortly. So the other part of our product is reports. It's a very different system from the first one, where first one was a real-time system. Suddenly, this gets divided into a daily reporting system. This is what the customers actually see. They see the reports. They don't see the raw data collected from the collection system. They see the reports that have been generated. This is done once a day. It is an offline process. It takes several hours. Since it is what customers see, we are very careful about releasing this. So before we release this, we have some tooling that allows us to check whether this data is correct on a very high level. So for example, if there is any data, if there are the major shows that they expect, for example, if there was a big show yesterday released, they would expect some social chatter about this show. If they don't see it, they can contact us before ever publishing this. So there is actually some manual data checking before this is even shown to the customers. This is so important. This is generated once a day. But before all of this manual checking happens, what we need to do is we need to generate this data properly, and this is a huge responsibility put on our code and on our engineering teams. What I mean by getting it right here is all the ways that I mentioned before: being accurate, being complete, the data being complete, and the data being consistent and stable. Why is it so important for us? So this is why I introduced you to the two current systems and their issues, because it is very different reasons depending on which part of the systems we are talking about. For collection system, the biggest challenge is that it is real time. Once we miss something, we miss a post coming from Twitter, we miss a post posted on a page, we miss some likes. There is complexity to it, but once we miss it, it is often gone. If we miss several hours of collection, we just don't have it. And if we just don't have it, we cannot sell it. And this is what customers pay for. If they have missing periods of data, they cannot do their analysis, whatever they want to do with data. We're basically not providing them with service. So this is very different from what you would see in a feature application. If Uber doesn't work for 2 hours and then starts working again, they lose money because of the service they provided, but only for those 2 hours. If we lose 2 hours of data, we never can get those data back. We can never sell those 2 hours again. And if those turn out to be very important 2 hours, it's usually more about days than hours, but this means that our product is flawed. Some of the customers will just not want it because it's flawed. Even worse, if we collect something with a bug, with a buggy release, we end up misleading our customers. So our customers see the number, but they have to trust us that this number is correct. A lot of our value proposition comes from the fact that they do trust us. We have been in business, I think we started in 2008. The actual metrics business was in 2011, 12-ish. Started when we started selling this data, so that's over 10 years now. And we are trusted by our customers to be good data. If we end up saying something incorrectly, they might repeat it. So for example, they might say, we have been the largest show on Twitter yesterday. And then we end up saying, okay, this was a bug, we had a problem. And then we have to do a press release. They have to read the press release. They have to do a press release. And nobody wants to say, you know what, we actually weren't the largest show on Twitter yesterday. It was some other show. So we obviously do not want that. They can get pretty angry about this when this happens. So we need to avoid this. This is why it's important in the collection piece. In the reports piece, there is a whole different set of problems with data. Once the report is generated, they tend to stay there forever. There are some exceptions to this, of course, but they generally are whatever they are generated. So if we generate an incorrect report, as I mentioned before, even releasing a fixed version of the application doesn't fix the report that has already been generated. Again, once those are published, customers can see them. They are very difficult to be retracted. While it is in principle possible to do what we call a backfill, we generally don't want to do it. It is quite complicated, takes a very long time, involves a lot of manual work of our engineers. And it also introduces a risk because we're doing something that we're not really supposed to do with our system. And this could mean that we introduce even more errors than we fix. If you're wondering why would it be so difficult to run an application again on past data, I can go into this on the break if you're curious. Feel free to grab me. But the short story is that the application basically changes constantly with all the developers running on it. So you can imagine something like different methodology every couple of months, different data schemas every couple of months. And if you have to generate all the data with all the changes, you just don't have the code that was working 5 months ago, and you can't run it anymore because it's gone. So these kind of problems. But if you're really curious, I can talk about it at length. So let me take a short break now. I hope you understand why I believe data quality is important and why it is so critical to our customers. So how do we deal with it? It is a big problem. It is a very varied problem. There are different aspects to it. So being engineers, of course, we decided to create some tools for quality, for data quality. We have two major tools. One tool is in a very boring fashion called Quality Dashboard. This is not terribly interesting naming, but what it does is actually pretty ingenious. It is what we call an incremental process. We have generally many technologies in our system. This is interestingly created in Scala and RabbitMQ for event processing style of programming here. It's a very unorthodox technology stack for us. There are some people among here who will be able to talk about Scala in this at length. I think Michał is sitting somewhere in the audience. The principal idea behind the Quality Dashboard is fairly simple. We have two environments. We have built what we call a pre-production environment, where we try to rebuild the entire system as it would be in production and run it in parallel. We try to make it as close as possible to the production system. It is not always possible, unfortunately, due to cost and other limitations, but we strive for this. And the assumption here is fairly simple, that we had good version of data at some point in the past. It was validated by our customers, it was validated by our product team and by our business analytics, and they said this data is good. If you introduce any change to this data, we need to make sure that this change is good. So what we do is every week, we release every week because we have 20 people working on this, so there is something to release almost every week. When we introduce a feature, what we do is on Fridays usually, we release a new version to pre-prod. So we have the old version, V1 in this example, running on Friday and further in production, and then we have new version with new changes, with new data generation, with everything running in pre-prod. Then we leave it for the weekend. On the weekend, usually not much happens from the engineering perspective, which is why we chose it. So it runs both versions in parallel. Those are different versions of code running on the very same queries for social media. So they are doing the same thing with new version of code. The assumption here is that once we come back on Monday, we can compare those two. And this is what Quality Dashboard does. I will show it shortly. And check if they are good and if they are similar. So what does the tool look like? The tool is not much to show actually when it comes to beautiful screenshots, unfortunately, because it just has a lot of numbers. It has a lot of numbers. Some of those numbers are green, which generally indicate good things, and some of those numbers are red, which do not indicate good things. So this type of comparison that I just mentioned is what we call a cross-environment reports. What this means is compare same data or same data queries between two environments with two different versions of code, hopefully. We look at the same TV programs and we match the data. So I can't really read it here, but this is a basketball game, for example, and it will be the data about it will be collected both in production and in pre-prod, and then we have like a whole data row that we match with each other. We obviously expect it to be exactly the same, which usually doesn't happen. We have a great many discrepancies every day. Some of them are actually expected. There are 3 categories of discrepancies that we expect. One would be that if we introduce a change that changes methodology, maybe that's a better way of counting posts for this TV program. So you would expect this TV program to have more posts associated with it, and then more likes, more everything. So this is a good change, right? Because it is an expected discrepancies. This row would appear here. There is another type of discrepancies, which is that social media platforms that we are using, which is Twitter, Facebook, Instagram, and YouTube, tend to be very sensitive to query timing. We can query, for example, a page for Facebook posts, and it will have 7 posts. If we query it from another system at almost exactly the same time, it might have 6 posts because one of them has not yet been synchronized across all of this Facebook's data centers. So this happens. We also have some timing issue where if one system just queries something 2 or 3 minutes before, it will have a different number of likes. If it has a different number of likes, this could also sum up into much differences. We try to mitigate those, but ultimately it comes down to somebody who is reviewing. There's a person reviewing all those discrepancies. They have some tools where they can note this kind of problem, that is that kind of problem, and then the row disappears as kind of validated and okay. And the reason why the quality dashboard exists is the third type of discrepancies, which is when there was actually a bug introduced. So coincidentally, and this is a big coincidence, this happened today. So we actually discovered, Quality Dashboard has actually discovered a very major feature where on Instagram, we were just doing something wrong. Somebody has released a bug. But this is really, was it you? But this is actually why we have it. This is the reason for its existence, is that we have caught this in pre-production environment. What this means is that this data was never created in our production database. We do not have to backfill anything. We do not have to do any retractions to the customers. We are just going to either fix the issue or stop the release. I do not actually know which one we chose today. Talk to Hlib, he will probably be aware. So this is a piece that allows us to catch all the issues before they appear. And this is primarily how this tool works. There is also a second type of report, business logic aware reports. So I briefly mentioned those on the sales reports. You would want your days to sum up in 2 weeks. You would want your posts to have more likes as time moves forward. So you would expect some business logic rules. We also query for those. They can detect some inconsistencies, but to be fair, with a couple of years that this has existed, this mostly comes down to cross-environment reports and what one environment collects and what other doesn't. So very cool. This helps us with the ongoing data generation. Like if we check something every week and this is the same as production and we release it, we will have a good data generation system going forward. But what about past data? So what is past data? Past data is the reports that we have already generated in our production environment. Could it be broken? And it turns out that it could. And we have a tool with a more clever name, Hermes, which works with data regression. What this is and why is it important? So There is a piece of our application that basically just retrieves those reports from the database and shows them to the customers, either in the XLS or in the UI format. And this is a surprisingly complicated and large piece of code, which sometimes is broken. And we need to detect those kinds of issues. This is an easier problem. The harder problem is that sometimes we actually modify the data. So all of the reports live in the live database because we have to query them. This is why there is 14 billion rows of reports in our database. And if we have a broken enough software, we can actually start overriding those reports or changing them in an unexpected fashion. And this has actually happened. And Marcin will talk about this in detail later, because this is what spawned this tool, what caused this tool to exist. And it is a very big issue, because then we not only lose the data that we generate going forward, we could actually start losing the data that we already thought we had and was good. And it's very difficult to detect. So also here, the solution is fairly simple. So we similarly generate Hermes reports before deployment. We generate Hermes reports after deployment. What we use is, there is an existing feature of our application that allows generating XLS formats for our customers. They generally don't really like the UIs, so they want to download XLSs. We download those XLSs. We would download XLSs for an entire month, for example, before the deployment. Then in the same entire environment, after the deployment, we would download the same reports and we would check if they match. If they don't, unfortunately, the colors here are a little bit broken. If they don't match, this raises a red flag. This means that there was a change that either changed the data or it changed the way we get the data from the database. Either is suspicious and should be investigated. So fairly simple tool, but it does detect a lot of problems very early. There is, of course, some space for improvement in our tooling. There's always space for improvement. So in this case, one thing that we're thinking about is maybe we could prevent any modifications to the past data. It's easier said than done. In the case of previous tool that I mentioned, maybe we could have the discrepancies that come from timing issues or other predictable problems be smaller, so that we can only focus our human minds on problems that are actually caused by us. But all of those quality tools come together to our weekly release cycle, and we can check if what we're doing going forward and backward in time with the data is actually correct. As our product owner likes to say, this is the same person, it now takes 1 minute to look at the dashboard for what it took, for what took hours to generate and validate every single release with whenever major changes were done. So this is our tooling. It is really helpful. It is something that has allowed us to keep consistently high quality and keep many of our customers and actually grow the business over the last decade. That is all I had for today for you. I hope you enjoyed it. Thank you for listening. If you have any questions, this will be the time. And there is a microphone somewhere. So this is the call for the microphone. The microphone is coming if anyone has any questions. There's a question in the audience.
Maybe I will just use my voice.
Okay, okay.
What does it actually mean for your tool that the data is accurate? So how do you actually compare it with, let's say, the actual data which is in the social media? So do you take, I don't know, a manual like screenshot of the number of likes at some point in time? And
very good question. So as I said, the idea here is that you can't really know what is the result. But we have done some very extensive manual validations with some version of our software. And this version of the software was a gold standard. This has been validated. This has been working for enough time that customers would have reported any issues. They are very picky when you don't get their tweets. And what we're trying to do here is by incrementally adding on top of new version that doesn't break anything from the old version, we kind of promote this old gold standards. So assuming that the first one was correct and that changes are actually correct, the assumption here is that the result, new version, is also correct. And we have been doing this for, I think, like 5 or 6 years with every single release that we have done validation in with the past version. And this is it. And of course, there are also some validations performed by our business team. So they just have a dump. They just kind of check if it looks okay. Hope this helps. Okay, so thank you for listening. Thank you for coming today. That's all I had.